Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
The year 1945 marks a profound caesura in human history, a moment when a world war concluded under the terrifying glare of a new sun, born in the deserts of New Mexico and unleashed upon the cities of Japan. In the intellectual maelstrom that followed, the global public sought to understand the origins of this awesome power, and in doing so, turned to the scientists whose curiosity had unlocked the atom's core. Among these figures, Lise Meitner occupied a unique and deeply paradoxical position. Her pivotal work was the 1939 theoretical explanation of nuclear fission, yet it is her intellectual activity in 1945 that constitutes a distinct and crucial contribution, a conceptual work of synthesis, clarification, and moral reckoning. This essay posits that Lise Meitner's effort in 1945 to articulate the true physical nature and scientific context of the discovery, in the very shadow of its military application, represents a seminal act of intellectual stewardship. It was a rigorous framing of a revolutionary science, an anchoring of its fundamental principles against a tide of public confusion and political expediency, a contribution whose historical weight is only magnified by the simultaneous, conspicuous failure of the Nobel institution to recognize her foundational role. The intellectual landscape that Meitner navigated in the decades prior to this moment was one of both exhilarating promise and profound confusion. The 1930s witnessed a flurry of activity in nuclear physics, catalyzed by James Chadwick's 1932 discovery of the neutron. This new, uncharged particle proved to be the perfect tool for probing the atomic nucleus. In Rome, Enrico Fermi's group began systematically bombarding every known element with neutrons, producing a bewildering gallery of new radioactive isotopes. When they reached uranium, the heaviest known element, the results became especially perplexing. They believed they were creating transuranic elements, new substances heavier than any found in nature. For several years, this assumption guided research across Europe. At the Kaiser Wilhelm Institute for Chemistry in Berlin, a formidable intellectual partnership had flourished for 3 decades, a union of complementary talents. Otto Hahn was the era's preeminent radiochemist, a masterful experimentalist with an uncanny ability to isolate and identify minute quantities of radioactive substances. Lise Meitner was his indispensable counterpart, a brilliant physicist who provided the theoretical framework, designed the experiments, and interpreted the physical meaning behind Hahn's chemical findings. She was the intellectual engine of the collaboration, relentlessly pushing for a coherent physical model to explain the strange products emerging from their uranium experiments, products whose chemical behaviors stubbornly refused to align with those of elements neighboring uranium in the periodic table. This persistent anomaly, this deep scientific puzzle, formed the genesis of the discovery. The political upheavals of the time, however, would irrevocably fracture this partnership. With the Anschluss of Austria in 1938, Meitner's Austrian citizenship afforded her no protection from Nazi racial laws. She was forced to flee Germany in July of that year, finding a precarious refuge in Stockholm, stripped of her equipment and her intellectual community, yet remaining in constant, urgent correspondence with. The moment of epiphany arrived with the stark clarity of a winter morning. In late December 1938, a bewildered Otto Hahn wrote to Meitner. He and his junior colleague Fritz Strassmann had performed exceptionally careful chemical analyses of the uranium bombardment products. They had tried to isolate what they believed to be isotopes of radium, an element chemically similar to barium, but a substance they expected to find. To their astonishment, the substance they had isolated was chemically inseparable from barium. Hahn, the chemist, could only report the result, writing to Meitner with a sense of wonder and disbelief. Perhaps you can come up with some fantastic explanation. We ourselves realize it can't really burst apart into barium. The letter reached Meitner during the Christmas holiday, which she was spending in the small Swedish town of Kungälv with her nephew, the physicist Otto Robert Frisch, during a no-legendary walk in the slough. Aunt and nephew grappled with Hahn's seemingly impossible result. It was here that the pieces of the puzzle, gathered over years of research, finally snapped into place. Meitner, with her deep grasp of nuclear physics, brought forth Niels Bohr's liquid drop model of the nucleus. In this model, the nucleus behaves like a droplet of liquid, held together by the strong nuclear force which acts like surface tension. She reasoned that the absorption of a neutron by the massive uranium nucleus could cause it to become unstable, to wobble and elongate. The repulsive electrical force between the protons would then overcome the cohesive nuclear force, causing the nucleus to constrict at its center and split into 2 smaller droplets, 2 lighter nuclei. Barium, with its atomic number of 56, and krypton, with its atomic number of 36, would sum to uranium's 92. The chemistry was suddenly explained by radical new physics. This was a new type of nuclear reaction, a cleavage of the atom itself, which Frisch aptly named fission. Their insight extended beyond the mechanism. Meitner performed a swift, critical calculation based on the mass defect of nuclei. She knew that the mass of a heavy nucleus is slightly greater than the sum of the masses of its constituent protons and neutrons. Conversely, the fragments of a fission reaction, the two smaller nuclei, would have a combined mass slightly less than the original uranium nucleus. This missing mass, she calculated using Albert Einstein's famous equation E equals mc². The equivalence of energy and mass multiplied by the square of the speed of light must be released as a tremendous burst of energy. A calculation yielded a value of approximately 200 million electron volts per fission event, an amount of energy orders of magnitude greater than any known chemical reaction. This was the source of the atom's power. A seminal paper, Disintegration of Uranium by Neutrons, a New Type of Nuclear Reaction, was published in Nature in February 1939, providing a complete theoretical explanation for Hahn and Strassmann's experimental data. By 1945, this pure scientific insight had been weaponized with terrifying efficiency. With the bombing of Hiroshima and Nagasaki, Meitner was abruptly thrust into the global media glare, often under the sensational and deeply unwelcome title of the mother of the atomic bomb. Her intellectual work of this year was therefore one of public clarification and profound moral dissociation. In a series of widely reported interviews, including one with Eleanor Roosevelt, and in review articles she prepared for scientific journals, Meitner undertook the critical task of establishing the authoritative narrative of the discovery. She consistently and patiently explained the physics. She emphasized that the splitting of the uranium atom was a consequence of fundamental physical laws, predictable from Bohr's liquid drop model and Einstein's mass energy equivalence. She meticulously traced the history, positioning the finding as the culmination of an international, collaborative, and curiosity-driven scientific quest, a world away from the secretive, goal-oriented Manhattan Project. Her work was to reclaim the discovery for pure science. Simultaneously, she drew a sharp, unambiguous moral line. She expressed deep sorrow and regret that her field's beautiful discovery had been harnessed for destruction. When pressed about her role, she was resolute, stating that she and her fellow scientists in Berlin never for a moment thought about a bomb. Her 1945 synthesis was thus a dual contribution. It was a definitive scientific pedagogy for a world grappling with a new physics, and it was a powerful ethical testament. She asserted the scientist's responsibility to knowledge while disavowing responsibility for its militaristic applications, establishing a paradigm of conscience that would echo through scientific corridors for decades to come. The reception of Meitner's contributions, however, culminated in one of the most debated episodes in the history of science. In November 1945, the Royal Swedish Academy of Sciences announced that the 1944 Nobel Prize in Chemistry was awarded solely to Otto Hahn for his discovery of the fission of heavy nuclei. The decision represented a profound misreading of the intellectual history, a critique by omission that sidelined Meitner's central role. The Nobel Committee, clinging to a rigid disciplinary boundary, chose to honour the chemical finding, the identification of barium, as the singular discovery. Hahn, in his post-war position, did little to correct this narrative. His acceptance speech and subsequent accounts tended to frame the discovery as a progression of chemical experiments, with the physics interpretation by Meitner and Frisch as a subsequent, separate step. Historians of science now overwhelmingly reject this compartmentalization. The Berlin research was an integrated, interdisciplinary effort for which Meitner was the acknowledged theoretical leader. The chemical data from Hahn and Strassmann were anomalous and inexplicable without her physical insight. The problem was fundamentally a physics problem that was solved when Meitner correctly interpreted the surprising chemical evidence. Her forced exile, the difficulty of communication, and the complex political atmosphere of post-war Germany all conspired to obscure her essential contribution from the view of the committee. This institutional failure, however, had an ironic effect. By denying her the formal accolade, it threw into sharper relief the power of her own voice. The injustice of the Nobel decision lends even greater weight to her intellectual work of 1945, where she, without the platform of a laureate, successfully defined her own legacy and the true story of fission on the world stage, a legacy of both scientific genius and unshakable moral integrity. In conclusion, Lise Meitner's intellectual output in 1945 was far more than a retrospective summary or a personal lament. It was a rigorous and necessary act of scientific and ethical consolidation. While her 1939 paper with Frisch laid the foundational theory of fission, her public and scholarly work in the year the world awakened to its consequences served to cement that theory's meaning, context, and moral implications. She provided the definitive explanation of a complex physical phenomenon, Countering misinformation and framing it within the noble tradition of pure research, she simultaneously articulated a powerful stance on the responsibilities of a scientist, creating a clear distinction between the pursuit of knowledge and the development of weaponry. The shadow of the Nobel Prize controversy only serves to highlight the integrity of her position. Denied the ultimate institutional recognition, her voice in 1945 became her platform, her clarity became her authority, and her conscience became her enduring legacy. Lise Meitner stands today as a figure of immense intellectual stature, a testament to the power of a single mind to perceive a new reality within the atom's core, and equally to the strength of a single conscience to navigate the turbulent waters of a world transformed by that perception. Her work reminds us that the greatest scientific discoveries demand not only brilliant interpretation but also profound wisdom.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.